Okay, this is notes over symmetry. Is a function even? Is it odd? Or is it neither even or odd? Symmetry. Even is symmetry about the y-axis, meaning if I took the graph and I folded it vertically on the y-axis like a hot dog, and I folded it there, if the graph touched itself, then it would be even. So I'm going to fold it on the y-axis, and if it's the exact same points on either side, or the graph touches itself, it's even. Odd is symmetry about the origin, meaning I can spin the graph upside down and it lands on top of itself. That is odd. Okay, now the first time that I learned, and if you don't have either of those, that's neither. There is no symmetry. Now, not that kind of symmetry. All right, now, the first time I learned this stuff, I had to come up with a way to help me remember it, because just folding it and envisioning it turning, I couldn't do that. So I started looking at the X and the Y coordinates and what happens there, and it helped me out a lot. But if you look at this graph, if you fold it on the Y-axis, it will touch itself, and it is even. Now, another way to look at it is if opposite X values, meaning 1 and negative 1, 2 and negative 2, 3 and negative 2. If opposite X values have the same Y values, then the graph is even. So if I were to look at 2 here and negative 2, at negative 2 this graph is at 3, and at 2 it's at 3. That's even. Now you don't want to just pick one graph. One point. You want to pick several of them. But this is a hand sketch graph, so it doesn't do as well as one that was computer generated, but you get the idea. So opposite X values have the same Y values, it's even. You can fold it on the Y-axis, it touches itself. A graph that is odd, like this one, if I took it and I totally spinned it upside down, this part right here would land here, and this part right here would land here, and it would land on top of itself. That is odd. All right. I could, when I first started learning this, because we didn't learn this when I was in school, so I had to teach myself. So when I first started learning this, I could envision folding it on the y-axis. I could see that in my head. However, I just could not see spinning something upside down and looking at it. So again, my opposite X values, you want to look at your opposite X values. You want to look at 1 and negative 1, 2 and negative 2 on the X axis and see what's happening with the Y. If they have opposite Y values, then it's odd. So if my Y signs are opposite, then it's odd. So if you look at 2, it's at 5. And if you look at negative 2, it's at negative 5. That is odd. If you look at 1, it would be at 1. Look at negative 1, it'd be at negative 1 if I sketched it right. But that's an odd graph. Okay, come over here. Now, this one looks very similar to the first example I gave because it's another parabola. However, its axis of symmetry is way over here at x equals 3. Its axis of symmetry is not on the y-axis. So because I can't fold it here, I've got to be able to fold it on the y-axis. It is neither. Plus, if you look at opposite x values, if you look at 1, it's at negative 1. If you look at negative 1 over here, it's way down here at negative 5.5 or 6. So the opposite x values have to have the same y values for it to be even. So although this graph looks even, it is not, because it's not symmetric to the y-axis. This one is odd. I can take this and spin it totally upside down, and it will land on top of itself. It's odd. 1, 1, negative 1, negative 1. It's odd. This one is even. If I folded it on the y-axis, it would touch itself. This one is odd. If I spun it upside down, this would land here, and this would land here. This is an odd graph. All right. To determine whether they're even or odd and you don't have the graph, obviously you could graph it and tell. But if you don't have it and you're just looking at the equation, what you do is you substitute in negative x for the x in the equation. Every time you see x, and wherever you see x, You substitute negative x into the equation and reevaluate it into the function and reevaluate it. Negative x squared will still give me positive x squared, and so therefore these are exactly the same. If I end up with exactly the same equation, then it's even, and I do here. The shortcut thing to remember here is that the sign is only going to change when you have an odd power of the x. So bear that in mind. This is an even power. The sign's not going to change. All right, come down here and look at x cubed. If I substitute negative x in and I take it to the third power, negative x times negative x is positive x squared times negative x is negative x cubed. So, and you will see that it did change sign. So if I have an odd power, the sign will change. When the equation ends up completely opposite, that is odd. So even, the equation, the function ends up being exactly the same. Odd, they end up having exactly the opposite sign. That would make it odd. If neither of those things happen, then it is neither. Okay, so I've worked both of these out. I've got negative x cubed. If you put negative x into that, that will give you, to the third power, that's going to give you negative x cubed, and negative x cubed is positive x cubed plus 1. Even if you don't understand all that sign stuff that I just said, remember that if it has an odd exponent, the sign will change when you throw that in, and this changed. Now the plus 1 is the same. This is different, but this is not different. So therefore this is neither. Remember, it has to be completely opposite to be odd and completely the same to be even. If I come down here and do the same, and I'm just going to, here's the work done, but I'm just going to go through the shortcut with you. If it's to the second power, the sign will not change. If it's to an odd power, this is to an understood 1 power. Got an understood 1 for an exponent. If it's odd, it will change. This is neither. Because although this is the same, this is opposite. Remember, completely the same to be even, completely opposite to be odd. All right, now, again, looking at opposite y value, opposite x values and y values. So here's opposite x values, same y values. Opposite x values, same y. That's even. Let's look at the next one. Opposite x values, opposite y values. Opposite x values, not even. Not the same, not opposite. That is neither. This is just looking at a table. Opposite x values, look, neither. Come on down and look at this one. This is an example of an odd one. Opposite x values, opposite y values. Opposite x values, opposite y values. It's odd. Thank you.